Okay, everybody, let's go ahead and recap the lesson. So we're talking again about these max-min problems, okay? This one's a little bit unusual because it's not really a max-min problem, but it's kind of like a rate problem. So we've got this conical water tank, and water's going into it at a rate of 40 centimeters per second squared. So that can at least be one equation. Volume is 40T. For every second, we get 40 cubic centimeters, okay, which is not a lot of water, but some. The water tank is 100 centimeters in diameter and 250 centimeters tall. Okay, now as the water goes in, the water is the exact same shape as the cone, and that's important. Okay, so the first question says find the volume of water as a function of the height. Okay, the height. Well, all right. So volume. The first thing I do is I use my volume equation, and I know volume equation is pi r squared h divided by 3, but I needed it to be completely in terms of height. So I found a ratio. I know the water is constantly changing as it rises, but the radius of the water and the radius of the tank they correspond in the height. So I went the radius of the water to the height of the tank goes to the radius of the cone to the height of the cone. Okay, so it's just a simple ratio, and then we find out when we solve it that it's really a 1/5 ratio. So if I solve for r is equal to h over 5. So I put that into r. And so I went h squared, instead of r squared, I went h over 5 squared. And then I simplified that. That's h squared over 25. I just multiplied that. And then I simplified a little further, and I got pi h cubed over 25, because that's 25 times 3, over 75, okay? Okay, I've got the first part done. Now the second part talks about representing h as a function of time. Okay, so then if it's a time, I got to get this equation in there. So I take this equation, which is a volume, and I put it right there. So I rewrote it here. So we have 40T, because that's my volume, is equal to pi h cubed over 75, because that's what I simplified it to. And I just solve for h. Okay, let's multiply this by 75 divided by pi, and took the cube root of both sides, and here is what I got. Okay, I finally got this equation here in terms of height with respect to time. Okay, so that way if you want to monitor the height, you got a stopwatch, you can just time it. Okay, and then I said, well, how long does it really actually take to fill the tank? So we'll get a radius. So if we fill it, tank's full, radius is 50, height is 250, and we just figured out that the volume would be about 654,498 centimeters. We divided that by 40 because it fills at a rate of 40 centimeters per second. So we came up with, where was my answer? Oh, so eventually we converted it all the way down to 4.5 hours. Divided by 60, divided by 60 again, okay? All right, the second question on the back, we have a rectangle that's inside of a parabola. So if I move this like a cursor, if I move this point up and down, I could either have a flat looking rectangle or I move the cursor up here, skinny rectangle, but where should I put this to make it the biggest perimeter? So I don't know, okay, for perimeter, let's see. First of all, perimeter, I'd have my square, and then this is whatever the x value is. So I get x, and the same thing down here. So I'm looking for the perimeter of the rectangle. That's my x value, x value, x value, x value. So I've got 4 of those. And the height of the rectangle has got to be y. So my perimeter is a 4x plus a 2y. I need to do it in terms of x only, so I plugged in my, since it's contained by the parabola, I plugged in 16 minus x squared in for y, and I simplified it. Okay, now I could graph this. I could graph this equation to find the maximum, but I used my negative b over 2a. I thought that was easier, and we wound up with about an answer of 1. Okay. So once I get the 1, I plug it back in. I get a point at 115. Okay, so then I know my perimeter has to be 34 units. Okay, perimeter domain is the size of the x's. Anywhere from 0 to 4 is the domain of my x's. Okay, and that's all I have. It's kind of fast, I know, but if you have any questions, come see me. Okay.